The biggest things in the universe will shock you. You think Mount Everest is big? Cute. You think the Earth is massive? Adorable. You think the Sun is enormous? We're not even close to getting started. Because the biggest things in the universe are so large that every word we normally use for size, giant, massive, colossal, completely falls apart. These aren't just bigger versions of things, you know. They are so far beyond your intuition that your brain will quietly give up trying to picture them and just accept the numbers. And by the end of this video, your sense of scale will never be the same again. We're going on a journey today, starting from things you can almost wrap your head around and climbing step by step until we reach structures so unimaginably vast that scientists had to invent new ways just to describe them. This isn't just about big numbers. It's about reframing your entire place in reality. Because when you understand how big the universe actually gets, you start to see yourself and everything you've ever worried about very differently. I've spent a long time breaking down astrophysics and cosmology into content that actually lands. Not just facts, but the feeling behind the facts. The sense of vertigo that hits when scale stops being abstract and starts being real. And this topic? This is the one that stops people cold every single time. So let's do this right. Here's the plan. We'll start with stars, because most people have no idea how wild those get. Then we move to nebulae, then galaxies, then galaxy clusters, then superclusters, and finally the largest structure ever mapped in the known universe. Each step is going to make the last one look like a rounding error. Every layer we climb, everything beneath it shrinks to nothing. Let's go. Start with the Sun. Our Sun is about 1.4 million kilometers wide. If you hollowed it out, you could fit roughly 1.3 million Earths inside. That sounds insane already. You could stack Earths like marbles inside a beach ball and still have room for more. But our Sun is actually a pretty average star, medium-sized. Nothing special in the grand scheme of things. It is so ordinary among stars that astronomers classify it as a yellow dwarf, a name that sounds almost dismissive. And it should, because what comes next makes our Sun look like a dust particle. Now meet UY Scuti. For a while, it was considered the largest known star. It's a red hypergiant sitting about 9,500 light-years away. If you placed UY Scuti where our Sun is, its surface would extend past the orbit of Jupiter. Jupiter, the planet that takes 12 years to go around the Sun. That's how far out this star's outer atmosphere would reach. Our entire inner solar system, Mercury, Venus, Earth, Mars, would be swallowed whole, deep inside the star, with room to spare. You wouldn't even be close to the surface. You'd be buried inside it. And UY Scuti isn't even alone at the top anymore. Stars like Stephenson, 218, have been measured at even larger sizes. So enormous that light would take hours just to travel around the circumference. Hours. Light moves at 300,000 kilometers per second, and it would still need hours to lap one star. That is not a metaphor. That is geometry applied to something so large that the fastest thing in the universe needs hours to go around it, once. But stars are just the beginning. Let's scale up, way up. Now we're looking at nebulae, the clouds of gas and dust that float between stars, where new stars are born and old ones die. You've probably seen pictures of the Eagle Nebula, the famous pillars of creation image. Those pillars look small and elegant in photos, almost delicate. In reality, each pillar is about 4 to 5 light-years tall. 1 light-year is roughly 9.5 trillion kilometers. So those gorgeous columns are over 40 trillion kilometers from base to tip. The full Eagle Nebula stretches about 70 light-years across, 70 years of light travel just to cross one cloud of gas. Now consider the Tarantula Nebula, sitting in our neighboring galaxy, the Large Magellanic Cloud. It spans nearly 1,000 light-years. If it were in the same position as the Orion Nebula, our closest major nebula, it would cast visible shadows on Earth at night. You'd see it with the naked eye, big enough to cover a chunk of sky the size of your fist, held at arm's length. It would be bright enough to see in daylight. A glowing, sprawling cloud of gas and newborn stars, visible without any equipment, dominating the sky. Still with me? Good, because we're just getting warmed up. Let's talk galaxies. Our Milky Way is a barred spiral galaxy. It's about 100,000 light-years across. That's the distance light would travel in 100,000 years of uninterrupted travel at 300,000 kilometers per second. And inside it, somewhere in one of the outer spiral arms, in a completely unremarkable location between two minor arm structures, is our solar system. One star, one tiny system. In a galaxy of 200 to 400 billion stars, we are not even in the interesting part of our own galaxy, but the Milky Way. Also not the biggest, not even close. IC 1101 is a supergiant elliptical galaxy, sitting about 1 billion light-years away. It spans roughly 4 million light-years across. Our entire Milky Way could fit inside IC 1101 about 40 times over. The Milky Way isn't even a suburb in this thing. It's more like a single grain of sand on a beach that stretches for miles. And IC 1101 contains an estimated 100 trillion stars. 100 trillion. If you counted 1 star per second, every second of every day, you would still be counting long after the sun burns out. Long after Earth is gone, long after the solar system itself has ceased to exist. Okay, pause here for a second, because I want to ask you something. When you look at the night sky, when you see all those stars and it feels vast and overwhelming, does it feel big to you? It probably does. It should. But everything we've talked about so far, every star, every nebula, every galaxy, is about to become a footnote, because we're now moving into territory that most people don't even know exists. Galaxy clusters. Galaxies don't float alone through space. They're gravitationally bound together in groups and clusters. Our Milky Way is part of a small group called the Local Group, about 54 galaxies, spanning around 10 million light-years. Cute little neighborhood, cozy even, by what's coming. But galaxy clusters are something else entirely. The Coma cluster, for example, contains over 1,000 galaxies, all packed into a region about 20 million light-years across. The Virgo cluster nearby has more than 1,300 galaxies. These aren't individual stars we're talking about. These are entire galaxies, each containing hundreds of billions of stars, all clumped together in one enormous gravitational family, bound by forces operating across millions of light-years. And clusters themselves cluster. They form what are called superclusters. Our own local group sits on the outer edge of the Virgo supercluster, which spans about 110 million light-years and contains over 100 galaxy groups and clusters, more than 1 million galaxies in total. 1 million galaxies in one supercluster. And our address within it is basically the equivalent of living in a small town on the outskirts of a continent. But even that, even a supercluster, is not the biggest thing we've found. Not even the biggest thing we've mapped. Here's the payoff. The thing that genuinely floors people every single time. In 1989, astronomers discovered the Great Wall, a colossal sheet of galaxies stretching 500 million light-years long. People called it the largest known structure in the universe. Scientists wrote papers about it. It was considered a landmark discovery. And then, in 2013, they found the Hercules Corona Borealis Great Wall. It measures approximately 10 billion light-years across. 10 billion light-years. For context, the observable universe is about 93 billion light-years in diameter. This one structure takes up roughly a tenth of the entire observable universe. 10 billion light-years of galaxies, filaments, and cosmic voids, all connected into a single gravitational web structure. It is so large that it technically challenges the cosmological principle, the foundational idea in cosmology that the universe is roughly uniform at large scales. Because this structure is so enormous and so concentrated in one region, it shouldn't exist according to older models of how the universe is organized. And yet, there it is, sitting in the data, confirmed by multiple surveys. The universe built something that broke our own assumptions about the universe itself. Take a breath. Let's bring it all the way back. We started with our sun, already 1.3 million times the volume of Earth, already capable of fitting over 1 million Earths inside it. Then we zoomed to stars like Stephenson 218, so large that light itself takes hours just to circle their circumference. Then to nebulae stretching thousands of light-years, vast clouds of gas that birth entire star systems across timescales longer than Earth has existed. Then to galaxies, our Milky Way with up to 400 billion stars, dwarfed completely by IC 1101 with 100 trillion. Then to galaxy clusters containing thousands of entire galaxies bound by gravity. Then to superclusters containing over 1 million galaxies. And finally, to the Hercules Corona Borealis Great Wall, 10 billion light-years of connected structure, one of the largest things that has ever been measured anywhere in the known universe. Everything is bigger than you think, every single layer. And every layer makes the one before it disappear. Now here's what I want from you. Drop a comment below. Tell me which part broke your brain the most. Was it the star that would swallow Jupiter? The galaxy with 100 trillion suns that makes the Milky Way look like a grain of sand? Or the structure that spans a tenth of the entire observable universe and shouldn't even exist by our own models? I genuinely read every single comment, and I want to know where your mind went. If you want to keep going, and I think you do, I've got a video on how the universe will actually end. The final stages, the last stars, the last black holes, the last faint whisper of light before everything goes permanently dark. It's a lot heavier than this one, in every sense. Link is right here. Until then, stay curious. The universe is far stranger, far older, and far bigger than any of us were ever told.